Hello everyone, here's Mustafa. In this video, I'll speak about how we can prepare a solution. Let's get started. Before we start speaking about how we can prepare a molar solution or a solution in the lab, we have to agree about some basic points. First of all, when we are speaking about preparing solution, we always consider the concentration, which is C. C is equal to N over V. What is N? What is V? V is the number of moles, and V, of course, is the volume, which is measured in cubic decimeter, cubic centimeter. Okay, so we can know from that that the unit for concentration is mole per cubic decimeter. Okay, in the lab, we have a graduated cylinder that is used to measure the volume, which is this one. We can see here that the unit here is milliliter. What is milliliter is same as cubic centimeter. And of course, we have to always remember that we can convert from dm cube or cubic decimeter to cubic centimeter, or the other way around by just multiplying by 10 to the power 3 cubic centimeter. So dm cube is equal to 10 to the power 3 cubic centimeter. Okay, so this is for calculating the volume of the solvent. Okay, we have also solute. How we can calculate the solute? We do not have a device that could be used to calculate the number of moles. But how we can calculate the number of moles? Okay, it's very simple. We have a formula which is telling us that N, which is the number of moles, equal to the mass over the molar mass. Why we are using this formula? Because we have in the lab something called scale, and this scale could be used to find the mass of any substance in grams. And of course, the molar mass could be calculated using the molar masses of the substance that are, or of the element that are making this substance. So for example, if you're preparing NaOH, if you're using NaOH, you already check the periodic table and you will find that the molar mass or the mass number for Na is 23, for oxygen is 16, for hydrogen is 1.01, and this is what you will use to calculate the molar mass. But for the mass, you will just put the amount, the desired amount on the scale, and you will be able to find the number of moles that will be used here to calculate the concentration. So these are the basic things that you have to know before preparing a solution. That we have concentration, we have number of moles, we have volume. We can use this graduated cylinder to find the volume, to find the desired volume. We can use the scale to find the mass of the substance. Then we can find the number of moles and to put that in the formula for the concentration. Okay, now we would like to prepare 500 cubic centimeter, 1 mole per cubic decimeter solution of sodium hydroxide. What do we have here? We have our solid sodium hydroxide, we have a weighing boat, we have scale, flask, and our glass stirring rod. Okay, from where we should start? We should start from our numbers. We have here the 500 cubic centimeter, which is the volume and volume of the solution, the desired volume for the solution, and we have here the concentration. So we have C and V. So we agreed from a while that C is equal to N over V. Now we have to calculate the number of moles, C by V, number of moles of sodium hydroxide. We have the concentration here is 1, and we have the volume is 500. But we have here cubic centimeter and the cubic decimeter, so we have to unify the units. We will convert the cubic centimeter into cubic decimeter by multiplying by 10 to the power negative 3. So the number of moles of sodium hydroxide is equal to 0.5 moles NaOH. Okay, this is the number of moles of sodium hydroxide, but we do not have a device that could be used to measure the moles. But we already have a scale. How can we use this scale? We can use this scale to measure or check the mass, M. And we already have a formula which is telling us that the N, which is the number of moles, equal to mass over molar mass. Okay, so we already have the number of moles and the molar mass. How we can calculate the molar mass? Molar mass for NaOH from the periodic table, we can find the mass numbers of the elements: 23 for sodium, we have 16 for oxygen, and 1 for hydrogen. So we have the molar mass is 40. Okay, so let's written again. How can we find the mass? Mass is equal to N by Mr. What is N here? It is 0.5. What is the molar mass? It is 40. So we should have 20 grams of sodium hydroxide. Okay, let's move to the practical work. This is our calculation. We should have the mass is 20 grams of sodium hydroxide. So we have the mass of the sodium hydroxide that we will need to use. Here is our sodium hydroxide. We will put, first of all, we have to put the weighing boat on the scale. We make sure that the reading is 0. Okay, then we can use a spatula to take the sodium spatula is like a small spoon where we can take the solid sodium hydroxide and put it on the weighing boat. We have to be careful. The weighing boat should be first on the scale. We make sure that the scale is showing 0. Then we put our solid sodium hydroxide. We'll put, of course, 20 grams of sodium hydroxide. After we have our desired mass of sodium hydroxide, we'll put this solid sodium hydroxide into our flask. Then we should have distilled water, and we'll fill the distilled water till the 500 mark. Then we can use the glass stirring rod to mix our components, our solution components. And that's it.